Welcome to the last session of the day. We saved, obviously, the most thrilling one for last. This is going to be advanced container scheduling and management. First things first, what is container scheduling and why do you care about it? It's how your containers are placed and run on your instance. So in a lot of cases, that's going to be how much resources should I allocate to that task? Which task, given the choice of many, should I place that task on? And it goes beyond the resource usage a little bit to how do I schedule things? So it's not just about, do I have enough resources for this, or should I put it there, or have I balanced across subnets and availability zones? But I can actually schedule things also, and I can run them in response to something else. So if I have task number 1 that runs, I can run a second task in response to that. I could run it in response to a function. I could schedule it to run like a cron job, everyone's favorite, and run it every night at a certain time, or every day in the middle of the day, or something like that. So there's more than just scheduling and management, but those are the big things here. Almost all of you are here for my last 2 sessions, so I have some intro that we're just going to skip over. I think, like with everything else, though, management and scheduling are things that start to have really significant impacts once you get to a production system. So it doesn't really matter if I kind of tweak anything or tune anything or change anything when I'm just running a couple of containers or 1 container or 50 containers. And it doesn't even matter that much at 100 containers. But where it does matter is when I have a whole production system, and maybe for you a production system is 100 containers. But it does really matter about how efficiently I'm using my space, how efficiently I'm using my resources, how I'm getting the most out of the infrastructure that I have. So a lot of us might work for startups. I know that I worked at a startup before this, and I definitely did not want to pay to run any more instances than I had to. And part of, I think, what's really great about containers is that the utilization for monoliths for a lot of people was not that great of a percent, right? So since in order to have redundancy or high availability, I had to have that one copy of that one application running on several different servers. And maybe I was only using 10% of each of those servers. Maybe I was using 20% of one server because I had some other tasks running on it, but then 10% of the rest of them in my pool. So we have an opportunity with containers and microservices to really get the most out of the infrastructure that we're using. So pack my tasks a little bit more closely, use my space a little bit more efficiently. A couple of core components here. We'll talk about all of them, some in more detail than others. First is scheduling. So how do the tasks run? What do they schedule them in response to? Placement engine, that does things like, and we'll look at the whole flow and the order of operations, but how does the agent know where to place the tasks? So there's some seats in the front, by the way, if people are looking for them. And it's okay to walk in front of the camera. I think everyone's seen me like 4 times already today. So there's 2 seats up here. There's 2 more in that row. There's 2 over there. Or no, there's 2 over there. So if you're looking for a seat, come and join us. Sweet. You're also welcome to lurk at the back of the room with Adrian, who's lurking at the back of the room. So that's also fine if you don't want to come join us at the front. So for those of you that just walked in, scheduling engine. So how do I schedule my tasks? What do they run in response to? Placement engine. We'll go through the whole order of operations for this, but in general, I have multiple instances. And how does the agent choose which instance out of those many I should place my task on? Finally, you have extensions, and we will dig into that. First off, scheduling engines. So we have different types of schedulers here. So the first ones are the service schedulers, and that's the really common one, right? So within ECS, I have my tasks are separated out into services. Each service has its own scheduler associated with it, or the agent is really scheduling on behalf of the service, but I run multiple copies of my tasks. I spread those across availability zones and subnets. I also have a batch scheduler. So I didn't bring a reference architecture for this time because I think looking at reference architectures in a room is sad. And I don't think we should do that. But they're online, and I will send out links for them. But something that I actually think is a really nice architecture type for containers is batch processing. So how can I suck up lots of events and process them all at once, or go through them all sequentially and process the whole batch? So ECS and other container engines are actually really great for that sort of thing. And I don't think you hear about them quite as often as kind of the 3-tier web app, or I ran my application, or I changed it from a monolith and I ran it in containers, and that's also great. But there are some different types in here also that you can really get the most out of with containers. What's also really cool, or for a certain value of cool, I guess, is that if I have a cluster, so I have a staging cluster or production cluster, I probably have excess capacity there. It might not be a lot of excess capacity, but since I want high availability, I probably have multiple instances in my cluster that a portion of them are unused. And this is less of that is used if I'm using something like bin packing, which we'll talk about later. But if I have excess capacity, why not use that for other exciting stuff? So that might be event-driven processing, that might be batch processing, that might be daemon schedulers. I can use that excess capacity in my cluster because I have a little bit of excess because I need it for some things. But so deployments is one of them. In order to roll over tasks one by one, I need a little bit of excess space to start up new copies of the task. So I need my excess space for something, but I can also use it for more exciting things that don't necessarily need their whole instance dedicated to them. So instead of running a whole separate pool of resources or even a single instance just for batch processing or cron jobs or event processing, I can use the same pool and I can use up all my excess capacity so that I can get just a little bit extra out of my cluster. Placement engine. So before we start on this is one of the things that I've been talking about all day, but that there is a default here that does not require you to do anything. So you could take the easy option here if you don't have a lot of tuning that you want to do. You do not have to choose how ECS places your tasks. You have the option to customize how it places them and what strategies it uses, and you can get very fancy. That is not mandatory. It'll place tasks just fine if you don't do it. It will follow its own order of operations, and I'll talk about them. But what we're going to talk about right now is that this is 400 level excitement, is we're going to talk about the custom cool way, but it is not mandatory. If you do not do this, or if you do not find this is applicable to you, the agent will continue to place tasks by itself. So it'll go by instance that meets its hard requirements. So we've been talking about those, so memory, port, and CPU. And then it will balance by availability zone, and then it will go by least number of running tasks. So the agent, by default, will go to the ones, if I have 2 tasks that could fit if I have 2 instances that could fit my task, and one of them has 3 tasks running on it already, and one has 0, and they're in different availability zones, it'll go on the one with 0. So that's the default behavior. Yes?
Is there a chance that the same task is executed more than once on the same instance?
So the question is, because I'm going to get it right this time, I also have an Ethernet dongle, so life is great right now. I have gotten 0 VPN messages. I'm having a great day now. If you were in my Fargate talk and it was confusing because I kept running out of internet and couldn't get a demo to work, you're welcome to come to Helsinki, and I'll do it again on Thursday. So the question is there a chance that the same task will be executed multiple times in the same instance? Yes and no. Yes, if it doesn't require a port, so if it's not bound to a specific port, so like processing tasks often are not bound to a port, they're reading off a queue or something like that. Those, you can have multiple copies executing on the same instance. The expected behavior of those is that that's totally fine because it doesn't have a port. If there's enough resources to run it, it's fine to have multiple copies. If, however, it is bound to a port, unless you're using dynamic port allocation, you won't be able to run multiple copies because the behavior is that they'll both need the same port, and I only have one of them. So both yes and no, but if yes, it's probably because it didn't need a specific port, in which case that's fine for you. There is something which we'll get into. A lot of people are looking for a concept of one per host, which is how can I get one single copy of this task, not exceeding one copy of this task, to run on each and every host. So as long as that host is running, I need a single copy of that task. I need at least one, but no greater than one. That use case for a lot of people is for daemon schedulers, for logging agents, for monitoring agents. ECS does have a concept of that. It's not 100% what people are looking for, or it's not exactly what I needed it for. There's a lot of really interesting workarounds for this. What I did, and this is maybe the weird opsy way to do it, but I did it as part of user data. So I just started the container myself. People are laughing at me, but it works really well. Bash solves all problems eventually. There's an interesting blog post out there that I will link if I can find the link to it. But other people that were not me and did not find Bash an acceptable answer, that wanted it to be managed as an ECS service, have some interesting workarounds. So if I can find the blog post and people are interested in it, I will post it. So that was a very, as always, long and convoluted and distracted answer to that question, but I did answer it before I got distracted. Are there any other questions before we talk about task placement policies? Sweet. Okay. Task placement engine, which is more colloquial, I don't know how to say that word, but it's better known as task placement policies and strategies. So here's how it works. So I can allocate tasks based on specific tags as well. So we just talked about the default way of ECS allocating things, which is by hard constraints, so port, memory, and CPU, only sometimes port, but things like that. And then by availability zone, and then by number of running tasks. If you can also set specific ones, so it'll match against the constraints that you specify. So an example might be a specific AMI type. So say you have a cluster, you have multiple instances running on it, and you have some AMIs that are for just a regular ECS optimized AMI, and one that you've tuned to include something else. So you had some kernel settings on it, or you're using a different instance type, or you've done something special to that AMI, like, for example, install a package for your monitoring agent. So you could match based on that AMI ID. You could also match based on availability zone. So if you only wanted some tasks to be deployed to a certain availability zone, you could do that. Same with instance type, which you talked about. Distinct instances is a lot about what I'm just talking about with that one per host. So given the chance, put one of these on each distinct instance. Works for a lot of cases. It only gets a little funky at auto scaling, but we'll talk about that. You can add custom tags as well. So when ECS was first kind of getting started in beta, it turned out that people were using the same cluster. They were using a shared cluster, and then they were distributing their tasks within the cluster. So they had some instances that they wanted to run database tasks on, some that they wanted to run event tasks on, some that they wanted to run messaging tasks on. So they wanted to match based on custom tags, so that tasks that were supposed to be run in a certain kind of instance or on prod instances as part of their cluster, that they could do that. That is not how I've set things up in the past. I've usually done cluster level isolation, so a production stack, a staging one, a development cluster. But if you prefer to share one cluster, this is one way that you might be able to support it, is by defining the different instance types with tags and then writing a custom filter to place your task based on those constraints. The new order of operations, so cluster constraints, those are the hard restraints that I keep talking about. So I cannot make more CPU and memory without changing my instance type, unless I'm very special, maybe, I don't know. Port, which we talked about, depends on your load balancer type, but unless you're using application load balancer, that is a hard constraint. So the agent will satisfy those constraints first. Then it will look for custom constraints, and those are the ones that we just talked about. So things that I wrote myself outside of the actual placement engine. Then it will meet my strategy, which we're going to look at on the next slide, and then it will select my final instance. So hard constraints, custom constraints, strategy, if I've chosen one, and then select the final one. So if you're ever not quite sure, if you wrote a custom strategy and you're not quite sure why the agent is placing tasks in a way that doesn't meet your strategy, from experience, it's probably due to this order of operations. It's like middle school math class. But the order does actually really matter here. It will always follow this order when it places things. So if you write a custom policy, make sure that you write something in such a way that it works for you while it follows that order. Placement strategies. So we're going to go into all 4 of these. You have bin packing, you have spread, you have affinity, and you have distinct instance. Since these have been uncreatively named like everything else that I've talked about, I think they're somewhat self-explanatory, but we will dig into them. So bin packing means to pack things as closely together as possible. So use up all the space that you can on this instance before allocating to a different instance. So if I have one instance that has 10 tasks running on it and one that has 0, if I have space, so obviously if I fit those hard constraints, so if I have enough memory, port, and CPU to support that task, it will go on the one that has 10 tasks running. So this is really good if you're either trying to use your infrastructure as tightly as possible. Maybe if you have a development environment and you only want to use one server to support this, so you want to get as many as possible. I talked about it in the State of the Union this morning. A company called Segment uses that in production, actually, that they want to be able to cram as many short-lived tasks as possible onto the same instance so that they can fill up their whole cluster. You can use bin packing in production also, but it just says use this space as efficiently as possible before moving on to the next available instance. Spread, we'll try to distribute them as evenly as possible. So an example of spread might be to spread across availability zones. This actually is structured a lot like a math class today, so we will definitely go through exercises on all of these because this is 400 level, so we have examples. Spread, we'll distribute them as evenly as possible, so if I have 2 or 3 on everything and I have 1 on another, it will add the second one to that one before moving on. Affinity will let you do things in logical groups. So if I have a logger and a monitor, this is a stupid example, but if I have a logger and a monitor that I always want to be together, I can keep those as affinity. So I want one of A and one of B, and I always want A and B together. I can do that with affinity. And then distinct instance, attempt to run one copy on one host. So no more, no less. I'm not sure that 100% always meets that use case. It definitely will do distinct instance. But sometimes a little bit of funky behavior with auto scaling. So it is still an option though. You can also use these together. So this particular, I did not make this diagram, but it's pretty cool. I can chain these together so it will spread across availability zone, but it will bin pack within that. So if I have 3 open instances and I have availability zone A, B, and C, if A is pretty full, and B is pretty full, it will fill up, it'll try to bin pack while still also distributing between availability zones for redundancy. Does that make sense? Cool. It's kind of hard to explain, but you can chain these strategies together to benefit from both of them. So you can use resources extremely efficiently while also going for high availability, or you could do within availability zone, but also with affinity. So I want to deploy these pairs of tasks, but also spread across availability zone. So you're not limited to just one. You can chain them together. Just follow your order of operations. So what does a container manager do? So for ECS, the thing that's fitting this role is the ECS agent still. So it looks for available resources. It looks for changes in that amount of resources. So if I start up a new cluster and it has 10 instances associated with it, but I deploy 6 tasks, my container manager knows the available amount of resources when I started, but then it tracks updates to that number of resources as well. So as I deploy new copies or remove new copies or change the amount of resources allocated to a service, the container manager is responsible for tracking that. It's also responsible for tracking whether I can deploy. It has to follow these rules. So it has to look and say, okay, so I have 6 instances left and 4 of them have enough resources to support that task, but 3 of them are US East 1A, and 1 of them is US East 1E, and I already have tasks in 1A, so the only one left is 1E. So it's not your responsibility to follow these rules. You have to write them if you want them, but it's the container manager's responsibility to enforce those rules, check for accuracy, and keep track of those resources. So I've been talking about CPU and memory and ports all day because I love a good port conversation. Obviously, there are other resource constraints. So there are more than are on this page. Also, disk space is another one, which is always really exciting because Docker has very strange behavior when it runs out of disk space. IOPS, network bandwidth. So these are all constraints that are both tracked by the resource manager and that you have to respect. So some of these are things that you can tweak a little bit, both at the task and container level by changing how much resources you need to allocate to the task, but is also controllable via instance type. So I have some instances that are optimized for memory use. I have some that are optimized for CPU. So you can control some of these by selecting an instance type that's better for your workload. But in general, they are considered hard constraints. So without making some sort of change, I cannot make more of one of these resources. A good time to mention, by the way, is that one of the most popular questions I get asked is, but you have an ECS optimized AMI, and what if I spend a lot of time working on my own AMI and I would like to bring it myself to ECS? The short answer is you should feel free. You can use whatever AMI you'd like or whatever instance type you'd like. Some things that you need to remember if you're going to bring your own. So first is that it needs to be registered with the cluster. So that's 2 extra lines in something like EC2 user data. Tell it which cluster it is. You have to install and run the ECS agent if you want it to communicate back with an ECS cluster, so that it can do things like manage your containers for you. And you obviously need to install and run Docker, unless you know something that I don't know. So you can bring your own AMI. So if you've tuned something or if you've picked an instance type that you know is really great for your workloads, you are not limited to using the ECS optimized AMI. So how I would do this is I would either build my own AMI or figure out the instance type that I wanted. And since we know that I like to solve all my problems with Bash, I would add some stuff in user data possibly that either pulled what I wanted to or made sure an agent was running. But mostly a lot of people do something called the golden AMI, where they get the AMI, they make all their changes, and then they commit their own version of the AMI back there. It seems very old school because we're doing everything at the container level now. But for a lot of people that have workloads that are very specifically dependent on tuning CPU or getting the most out of their memory or a specific type of instance type, or if they've done kernel level changes, it is totally a normal thing to still have your AMI that is custom. So you can do that with ECS, but remember that you have 3 extra steps to do that, to register. All 3 of those extra steps, for some reason, are in different sections of the documentation, but they are all out there. If people would like to see them, I will tweet them or post about them if you would like to see all of the instructions in the same place. We just talked about this because I got ahead of myself, but it is the ECS agent that is responsible for pretty much everything that we're talking about today. I mean, you're responsible for picking your own instance types if that's something that you're interested in, or making your own AMI. But for things like resource allocation or enforcing rules or enforcing constraints or strategies, that's your ECS agent. A fun fact, the ECS agent is open sourced. So if you would like to see how the ECS agent works, or open pull requests or issues or comments, that is on GitHub. So the agent itself is open source. So you can look at it and talk to the team that way and offer suggestions. So the agent is pretty much doing most of your control here. So all of your resource control, it's coming from the agent. This is another diagram that's going to look really small from here, but will look much better on your, I'm sure, very large laptop screens at home. High-level picture of what's happening here. So you have the APIs that everything are talking to. So this is what's happening with ECS. So your agent is running things and it's communicating with the agent that's on all of your boxes. So if you looked inside your ECS cluster, right, everything has the ECS agent running on it. And that's what communicates back with ECS. So how it knows, okay, well, there's 6 of me in the cluster and my desired count for the service is 10, but I only have 8. That's how you keep track of things like that. And that's how the ECS knows what's happening on each of the hosts and what's happening with the services. You have the cluster management engine, you have the API that things can talk to, and you have the agent which communicates back with the communication service plus your key value store. So really high level. More things that are happening with the ECS agent. So we already know this is pretty much like the hub that's controlling everything on your ECS cluster. What happens when you register an instance? So if you have a cluster, and at a new cluster, you're registering several instances, but in a lot of cases, you're registering or deregistering an instance when your cluster scales up or down. So this is pretty much what that looks like. I register my container instance, and it reports a certain amount of resources. So here I have 2048 for CPU. I report that. If I do nothing, the instance will report all resources it has back to the ECS agent. Our ECS agent is responsible for our resource allocation, so it has to know. I do not have to report all of my resources to the ECS agent, so I can reserve memory. So we talked about how I could, one way to do logging or monitoring for me, which is not the best way anymore, but it is definitely a way, is to run containers that were not managed by ECS. So they're not part of a service, they're not being managed by the agent, but I can still run them on the box if I'm feeling so inclined. If I need to reserve resources for those containers not managed by ECS, I can reserve memory. So I can report not all of my resources back to the ECS agent. That means that the ECS agent can only modify and allocate and control the resources that I've reported back. So in some cases, it might be if I save half of my box for other tasks, I'll only report the remaining half of those resources back to the ECS agent. And you can do those here. So I can reserve memory, I can reserve ports if I wanted to keep a port and not let ECS manage it, and I can reserve UDP ports. So there are more of them, I believe. If you go to the ECS agent, it will list all of the options that you can pass back to it. So if you want to hide more resources from it, reserve ports, you can do all of that when you register your instance. How does the agent go about managing resource requests? When I schedule my task, it starts by looking at the available resources. So I obviously, if I don't have enough resources to run my task, it can't start. And some of you, me, have definitely gotten the message before where it says there's not enough resources to start this task. So this is the point where that message is being returned, saying there's actually nowhere that I can put this, so I cannot possibly start. And for a lot of us, we then have auto-scaling rules in the background saying, well, you don't have enough resources. You could put a rule here at that point where you could scale up in response to that. It's a little late because you've already run out of space and you can't start one, but you could scale in response to that. When you start it, you both look for how much resources are available, so what you should take away, and then you look for how much resources the application actually needs. So there's two parts going on there, and then you check against our cluster management engine, which we saw back in that first big diagram was part of ECS, was cluster management. If I have enough resources to support that task, I approve it, or the cluster management engine approves it. If I don't, I reject it. I send that message. People have asked about high availability here before. If you have one availability zone that is not functioning, the cluster management engine will continue to schedule tasks, but not in that availability zone. So if you're missing one availability zone, your cluster management engine will continue to schedule. So if there's an issue, it just won't schedule in that availability zone. So there's some fault tolerance that goes on there. So basically, it's isolated, so it is not availability zone dependent. So each of them, it schedules in each of them independently. If I've approved it, it goes to agent communication, and we talked about that's the part that communicates with all the ECS agents on all the instances. So if it's approved, it goes to that. It sends a state change request to that node. So that a new task that since your instance is starting, or since your new task is starting, and you can see all these messages, by the way. So ECS emits a ton of messages. So that tasks are starting, that are stopping, that are pending, that our instances are starting and stopping and pending, that you're out of memory, that you're out of CPU. You get messages for all of those. You can see them in the ECS console, but that's probably not the most efficient way to consume those messages. You can use something called Event Stream for CloudWatch logs. So you can shove all those messages at CloudWatch logs so you can consume them from ECS. And then you can either consume them in CloudWatch, or if you have a different logging and monitoring tool that perhaps makes graphs or something exciting, you can consume those from CloudWatch as well. Another good example of this might be that you can submit these to PagerDuty. So if you have low on disk space or CPU or memory across your cluster, or if X number of tasks have been, so a good one to catch for is that if your task has been stopped many, many times in n minutes, it's probably having an issue. And that's probably something that a human might want to involve themselves in. So if your same task has been stopped 15 times in 20 minutes, it probably is either getting killed because it's using up all the memory, or something else is wrong with it. So you can look for these kind of events, and you can consume them in CloudWatch or Alert in PagerDuty or something like that. So it does emit a lot of messages that are useful during this whole process. So this registering process and the task starting process. So once the agent communication service has approved this request, it's spoken to the agent. It opens a WebSocket connection between the agent on the host and the ECS communication service that it needs to change its state. And then the ECS agent on the host responds back and says that it's either performed or failed to perform the requested action. So it started the task, it's failed to start the task, it started and stopped the task, which is not great. So that's kind of the process that you're following through, and what's acknowledging what, and then what messages are being emitted. Does anyone have any questions about how the task states are being changed and how resources are being managed? Yeah. So reporting the question back, I'm not going to forget this time. What happens if the ECS agent dies or is unresponsive? So what happens to the tasks that are on there? And then what happens with scheduling, I'm going to guess. So a couple of things. So if the agent has become unresponsive, you won't be able to schedule and place tasks on that instance anymore. So this has happened to me before, and it did not affect what was currently running on that instance, but I was unable to schedule more or to communicate with that instance. So they were fine when they were running. Eventually what happened is that since that instance wasn't reporting anything back anymore, it was kind of stuck. I believe that there is better handling for this now. So what should happen is that if the agent has become unresponsive, you can't do anything else with that. And eventually that task will be reported. That instance you can't do anything with it. So it can't pass health checks, it can't talk to the agent. So task would be drained off and brought back up on another instance. So if your agent is stuck, there'll be some time when your agent's not responding. And it used to be that you'd find that out because you'd be like, well, I'm pretty sure I have enough resources, but you'd get a message back saying there's not enough resources. It's because if the communication service can't communicate with the agent on the box, you're kind of stuck. Like, it can't report the resources back, but you also can't deploy anything because it has to open that WebSocket in order to send the request to start up the new task. So what I've done in the past with those is I just kill them. There's no point in trying to bring it back, and I'm not attached to any of them. So I just kill it and replace it. And that's actually something that in the future I probably could have automated. If I checked for that and the agent was unresponsive after n minutes, just kill the host. There's no point because I'd rather have a working agent. So just let the host be replaced. Does anyone else have any questions before we power on? Yes. So repeating the question back, when an instance is scaled up or down because of auto scaling rules, the tasks are not set in connection draining state. They're just kind of ungracefully killed. Are there any plans to do something that's not ungracefully killing that? So that's a good question. I don't know off the top of my head what the plans are for that. I can say, which is only sort of, it's kind of relevant, but only sort of relevant, like all of my answers to everything apparently. You generally have to handle two things in your app. So what I found for a while through the load balancer is that it was, if I was auto scaling, it was being sent sig term correctly, and then then it wasn't draining connections, and then was getting sig kill, and then it was like, now I can't do anything anymore. So what we found is that we just had to handle both of them. That it was when it was scaling up and down, it was getting sig term, and then just not draining fast enough. So it looks like it's not draining connections, but it actually was just draining them very slowly, and too slowly for the auto scaling rules. So not 100% an answer, but what you can look at is, one, how are you handling the signal that you're getting from the load balancer? So are you shutting down fast enough in response to that instead of waiting for sig term, at which case you're kind of effed. It's videoed, so I didn't think I should swear. Alternatively, something that you can look at the load balancer level is how long have you set your connection draining timeout for, and how long is your auto scaling? Because if your connection draining period is really long, but you're trying to auto scale quicker than that, you might end up getting your signals a little bit confused also, because your connection draining period, if it's really generous, maybe your instance is coming out of service and your connection draining period is still going on. I'm not sure that that's supposed to be how it works, but I know that I was having a problem where I wasn't handling sig term and sig kill quickly enough. So we're talking about the same behavior, I think, actually, is that where connections are going to an instance that's in service, and it receives sig term, and connections still get sent to it, but it's already received sig term, so the process inside the container has already stopped, but new connections are still being allocated. There's that gap in between. Your process has shut down correctly, but it has not received the signal, and so it hasn't been taken out of service. I remember that we got around that behavior because we were having the same one, and I am trying to remember how we did it, but I'm pretty sure it was by changing the connection draining behavior at the load balancer level. So it was 2 years ago, so I'm not 100% sure that it's still either the right answer, or I don't remember what I did. But I do know that not a lot of people have been looking into the connection draining settings, and that is actually more helpful than it sounds, because you can customize how long it either tries to hold connections open or how long it takes to drain off the connections that are on there. So you can make that a little bit more aggressive, and it will speed things up a little bit. So I'd look into that. Yes?
I have a question regarding the bin packaging and
Sure.
the instance that shall be terminated.
Sure.
So typically with EC2 auto-scaling, you have certain termination policies.
Yes.
They terminate, the instance first with all this launch config, balance the availability zones, and so on and so on. So is there any easy way to make auto-scaling aware of, say, this instance doesn't really have that many tasks running on it, so pick that one up, and terminate this one instead of draining, 50 tasks out of it. Is there any easy way around that, or will the underlying EC2 autoscaling just work the usual way?
That's a great question, and I do not know. Sorry.
Most likely this could be solved with instance protection and a couple of other things there, and custom lambdas, I don't know, but what I'm asking, is there a feature or anything like that that would make this process easier?
So the question, which I've already said was a good one, with spoiler alert, was that with the auto scaling rules, and for something like bin packing, where I have a custom policy around that this instance is important to me, basically it's running many, many, many tasks, and this instance has almost no tasks. Is there anything that says to the auto scaling rules or termination protection, prefer to terminate this one first and not the one that has many copies of tasks running on it? I am not aware of a feature that does that. It sounds very interesting, though, because it seems like it would be something that you'd want as part of just the load balancer behavior, is if custom policies exist, respect the custom policies as part of termination protection. So I do not know, but I will ask because I am curious. And if we don't, I will ask someone if we can do it, because that's very cool. Yes, I will figure out a way to let you know if that happens. But that was really interesting. So if anyone knows, I'm sure there's a way to make it yourself, that you could do it with custom CloudWatch events, or you could write a Lambda function. There's always a Lambda function for everything. There's totally probably a Lambda function for that. But that would be really interesting to see if there was anything that would handle that as part of that load balancer. I do know that the custom policies from ECS are fairly new, as in within the last year. So it's very possible that someone's doing something that I don't know about also. That's very interesting. Does anyone have another question before we talk more about exciting things? Okay. As promised, because I'm hosting a math class today, we have some examples on how you can filter and match on attributes and how does it pick the right instance. There's not actually that much math. There's actually no math, but it feels like math class. So number one, so if you can't see this, by the way, as always, the slides will be posted. So I realize that the text is a little hard to read. So if you can't see, you'll see them when they get posted. So this is a CLI example of how I can match on this. So this is just matching on one specific attribute. So my attribute is that my instance type is anything starting with T2. And you'll see that I've used a wildcard there. So T2 dot wildcard. So anything in that T2 family would be matched by that wildcard, and I would be able to allocate my tasks that way. This one, I have no wildcard, so it will only match on ones that are T2 small. I can match with both of these together. So this one, T2, but only in US East 1A. And then for this one, you can also pass it a list. So if you don't want to use something like a wildcard, if you have 3 separate instance types, so for this one, smalls or mediums, I can also pass it a list of instance types and then filter on a secondary attribute. So this one would only match on T2 smalls or T2 mediums that were located in an availability zone that was not US East 1D. Custom attributes. This is the one where we talked about where you could filter based on an environment or a stack. So this one pass an actual target ID. So go by an instance ID, and then in typical AWS fashion, you can also pass it a key value pair. So the name, the custom tag is the stack value is prod. So I had to pass it both a name and a value. So the name of my custom attribute and then the value of that custom attribute. Some examples of how task placement actually works. So I am not going to read these whole expressions out loud because that's crazy talk. But it's passing the normal parts of my ECS call, so run task, but it's running a task, but also respecting some parameters. So running a specific task, it's running 5 of them. And then I'm passing this placement constraints argument is what I'm looking for here. So it has to meet my placement constraints. It matches a certain value of instance types, and it's not in 1D. So the diagram here, That's PowerPoint. That's cool. So my dots, although it has not worked as well on the projector as I anticipated it working, they are mostly making it inside the instance. So we'll just pretend that they all made it inside here. I try, guys. So slightly easier to follow or not less easy to follow, but an example of how the agent is thinking about managing and placing these tasks. So it fits the hard restraints that it has to meet, and then you pass it the custom ones, and then it distributes them within that. This one, you can spread across zone and bin pack. So that's the one that I said verbally but didn't have an expression for earlier. It's because it was coming later. I can spread but also bin pack while I'm spreading around zones. So it ends up looking something like this, that as long as I'm meeting my criteria and spreading along the availability zones, bin pack within that. So you can get pretty fancy on these. So, and again, the default behavior is also fine. There's no, you don't, unless you know what you're doing or you know that you have custom ones that you really know that if you really need custom ones, you definitely can do this. So you can bin pack. So by default, it will not bin pack for you. It will spread them pretty generously across availability zones and by least number of running tasks. That is totally fine. But if you want to write one of these, the way that you end up doing it, so an example from the console, you can work on the templates. So there's a couple like helper functions there. So balanced within a spread of availability zone, balanced within availability zones, but bin packed, just bin packed without respect for availability zones, your one task per host, but also there's custom. So if I wanted to customize it, I can use the helper to write my own. So I can choose the order that I want it to do. So for this example, it's spreading on availability zone, then it's spreading between instances, and then it's bin packing according to memory. So use up all the available memory on one instance before going to the next instance. So this will help you out pretty significantly. So you can keep adding these. So I have the blue add strategy button. So I pick my order of operations, but this stopped at 3. If you want to keep adding them, you definitely can. So you can really, really, really customize, make very granular the way that the ECS agent is going to manage and place these tasks for you. So if you want to use up all of your resources, if you want to spread very carefully, that is all possible. A little bit on scheduling before we wrap up. Just like your calendar for people, but for tasks. Couple things that I can do. So a good production example of this would be load-based scheduling. So I can scale up in response to CPU utilization, and you can see that my action here, instead of adding another instance, is adding another task. So when my CPU utilization, it goes above a certain threshold, add another task. If it goes way above a certain secondary threshold, add 2 tasks. You have to have the opposite to your rule also, so you don't want to just keep recklessly adding capacity until you've eaten up all the disk space and then you get paged. So you have to add that scale down. So in this example, there's a scale down one, but it actually works for any task level auto scaling that you're going to do. Definitely also scale back down. So if you get to the point where you're not using that extra capacity, make sure you scale down. My recommendation on those would be, though, to leave yourself a bit of a buffer. So if you scale and add one task when your CPU is greater than 80%, don't scale back down on 79%. I would leave it on maybe like 65 or 60 so that you're using a little bit of extra capacity, but that you're not flapping up and down with tasks going up and down, because you don't usually have like a smooth rise in CPU all the time. Maybe you have spiky CPU, or maybe you have spiky memory. So rather than flap up and down, give yourself a little bit of a buffer so that it's dropped again below that much lower threshold before you remove your extra task. But that works for load. Time-based scheduling, you can create scheduled tasks. You can run it a lot like cron jobs. So in this example, it's running at a fixed interval, so every 15 hours. But if you really missed cron expressions, this is your moment. So you could write your own cron expression, which I'm assuming you then have to Google because I have to Google it every time and then it never works. And then I'm like sitting there and it's like 4 a.m. and I'm like, why don't I remember Perl? And then I'm very upset about it. So you can write cron expressions. Alternatively, you can run them at a fixed interval. So in a lot of cases for people, the traditional kind of like log rotate jobs that run at 2 a.m., this is a way that you could handle that without resorting to actual cron jobs. So a bunch of different options that were not just three-tier web apps. So we had some batch jobs, we had time-based, we had load-based, and no one will ever want to hear me talk about memory and CPU ever again. So that is the end of our scheduled content. If anyone has any questions, I'm happy to take them now. Yes?
With all the different custom constraints,
Sure.
is there a possibility that there is an empty set of available instances, and so is the task not executed, or one of the constraints is blocked?
If it returns nothing,
Yeah, it's basically by filtering and filtering and filtering, eventually we get to 0 instances, 0 candidates.
so the question was, since I'm repeating them out loud, Paul's nodding at me from the back, is if I add enough custom constraints, would I eventually get to a point where my results was 0? So where I had no instances that I could place my task on. And gut answer says, yeah, I mean, I'm sure I could add so many custom constraints that I could no longer place my tasks. I wouldn't want to do that, but there's nothing to prevent you from adding so many custom constraints that it could not place a task anymore.
But the engine does prefer to execute the task, or like basically dropping one of these constraints, or just as I'm sorry.
No, it will. So the follow-up question is, does the agent prefer to? Would it prefer to execute the task if it could drop a constraint? It will not drop a constraint for you. It will continue. You're basically making an informed decision there and saying, I've added all of these constraints. And when we looked at our order of operations earlier, remember, so after it places things like memory, CPU, IOPS, bandwidth, port, stuff like that, it does your custom constraints. It listens to you. So you're saying, like every other problem in computer science, you're saying, I know better and I'm telling you what to do. So it's gonna follow you. So it is use at your own risk if you've chosen to eliminate your entire pool of compute, which would be funny actually. So please let me know if you do that. Does anyone else have a question? And if not, I'll wrap up and you can ask them after. Yes?
Typically in EC2 you have auto-scaling where you can scale up or down based on how far your alarm threshold was crossed. Is there a similar concept in ECS available? So say in EC2 you have, if the CPU average on all your instances went up from, let's say, 50 up to 90 and it just stayed there, you can choose to add 100% capacity immediately. So you don't necessarily add one instance, but you can add 10.
So you can...
Can you do the same on ECS?
Oh, so repeating the question, is there anything, assuming I'm understanding it right, can you respond to relative changes in how, so if you've gone from 50% utilization to 90% utilization, can you add 100% capacity instead of adding n number of tasks to respond to that? I've always done it the other way so that I had multiple alarms. So if my CPU had crossed 80, then respond this way. If it's crossed 95, respond in this way. So I don't know if I've ever done a relative jump like that. You can write custom alarms, so it's possible that you could handle some of this with a custom alarm that I don't know about. But I've always responded by giving it a specific action in response to a specific threshold. So above this, add this, and you can add more than one. So you saw in my example rule that if it crossed 80%, add 2 at a time and keep adding 2, and then you could change if you wanted to respond quicker, you could also change the, there's that period in auto scaling where it's like the cooldown period before it reevaluates in response to that rule. If you find that you're in situations like that, one, add more copies of the task at a time in response to that, but also you can change the cooldown period so that it reevaluates the rule quicker. So you'd add more capacity a little bit quicker. Okay. Oh yeah, go ahead.
There were
So the question was, how do I optimize the sizes of my, well, you said Docker images, and my clarifying question here is, do you mean the image size or the task? Okay, so the resources allocated to the task. I'm going to be thorough and also careful here and say that in general, the way that I've done this is I've started with the default or a little bit lower, and I've reevaluated based on the messages that I'm getting back. So I start at kind of a reasonable default threshold, and then I look at what the utilization is. So if it's a process that's running very little, and in the past they maybe would have used something like a New Relic or something to look at the actual resource usage. So I would keep an eye on what it's doing and then reevaluate as I watch logs. So I generally don't fool with it until I can see how the container's actually behaving, because I don't really, and I usually don't set hard limits until I know that a container behaves poorly by taking up resources. So I generally want to err on the side of go with a pretty sensible default and don't set a hard cap, and then only set a hard cap if I know that I have a process that's greedy that will take up all the resources on the box if I let it. So I tend to let them kind of self-moderate until they're killing other processes for being rude. I don't think I have a hard recommendation, because I think it depends on what kind of task you're running on it. So not every task is going to be the same. Yes?
How do you detect and monitor failed tasks, like containers that have elements that are broken? Use restarting the container detect that and roll back to a previous version?
So repeating the question is, how do you detect errors with failed tasks or ones that keep restarting because there's a problem? How do I detect that and then fail back over to an existing version that is working? So part of that behavior is inherent in ECS. So if you have a container that tries to start up and fails health checks, you will never drain off connections from that old version to go to the new version. You'll stay on that old one until it can successfully pass health checks. So that eliminates part of the cases. What it doesn't eliminate are the ones that starts up and then passes health checks and then immediately dies for something else, or it runs out of resources, or it fails to start up in the first place. So answering the second part first, if it tries to start up, in the past, I've listened for that event, so we can consume those with CloudWatch, and I've listened for that event, so like task revision X has failed to deploy, or whatever the exact text of that message is. I've watched for that, and then I've taken an action in response to that. So either I've alerted a human, or I've done a Slack message in a channel to say that, hey, your deploy is not working. But you could definitely use a Lambda function or something else and take an action in response to that. I've always alerted a person because I wanted someone to look into it before it turned into a 3 a.m. problem party. So that's what I would do, is I would watch for that message and then have a human go look. But that's something that you could automate. And a couple companies have done some really cool scaffolding around deployments on ECS to handle cases like that. So an example that there's a nice blog post of is BuzzFeed wrote something called Rig. They had a nice post, but they've basically built in a bunch of deployment logic and scaffolding around how do I handle things like failed deployments, revisions that don't work, things that don't go out. So a lot of people have built that based on their own cases. As for I would actually handle the resource usage the same way. So I would search for the part of the message string that was like container X has been killed for memory usage. I would listen for that, and I would watch for that event in the logs, and then I would tell someone so that they could go back and fix the task definition. Something that could be automated also, but I think at least to start, that's always something that I want to be aware of. So it's not just that I'm throwing resources at a memory problem just to get the event to go away. It's something that I want a person to say, actually, that process isn't working, and that's why it takes up all the memory. So short answer, watch for events, notify something or take an action in response to those events.
Just follow up with, is there an event for this kind of event, or do we look into logs for the ECS agent?
There is
Like, there was no event such that this monitoring these kind of logs makes it
So repeating the question, is there some sort of event stream for these events that I can watch to know things like has been killed for memory usage? There is Amazon ECS event stream for CloudWatch logs, which should be a bunch of the events. Alternatively, there are also events that you can get that are coming from the hosts themselves. So there's agent logs. You can get the actual Docker process logs. You can get var log messages from the host or whatever your distribution's equivalent is. If you have extra information that you are not finding is being consumed by the event stream for CloudWatch logs, you can also get those messages, and you can either push those to CloudWatch logs as well, or you can send them to another logging system. So event stream should have most of the ECS specific ones. So task started, task stopped, those should all go to the event stream for CloudWatch logs. But if there's other messages or like Docker process messages, you can get those from the host. And I would just put them to my logging system as well, so I could look at all of them. But I'm kind of a log hoarder, I think, so I would probably take all of them. Okay, awesome. Well, thank you so much for coming. It has been an exciting Containers Day. People will be hanging around to answer your questions, and if not, enjoy the rest of your evening.